Hi friends, this is the lecture number 3. Again, I am just telling you that before coming in this lecture, you must go in the previous lecture, then you must come here. So today we will discuss about the ratio test. What is the ratio test? For the ratio test, let sigma un be a series of the positive term series and limit n tends to infinite un plus 1 upon un is equal to lambda. Okay, if you have lambda is less than 1, then this series it is convergent. Greater than 1, then this is divergent. Equal to 1, then this is fail. Okay, so how to just if you have different type of question, so the question is how to judge that you have to take this this ratio test, because there are many tests. Okay, so how to judge that you have to take the ratio test. The best example is whenever you have any such type of factorial. Okay, if in the question you have any such type of factorial, then every time you must take this ratio test. Number first. Second, whenever you have such type of series, I am just giving you one question: 4 upon 1 plus 4 into 7 upon 1 into 2 plus 4 into 7 into 10 upon 1 into 2 into 3 up to so on something. Okay, now you can see that what is this? This is the product of the natural number. So you can say also that is also factorial. Okay, so whenever you have such type of series, so means a factorial. Whenever you have factorial, then you will use this ratio test. Or you have product of the some numbers, then you will use this ratio test. Okay, we are taking one example. Here you can see that there is also factorial. So it will be solved by the help of ratio test. So this is un actually. So un they have given us 2 to the power n factorial upon n to the power n. So what about un plus 1? In place of n you have to put n plus 1. N plus 1 is equal to 2 to the power n plus 1 factorial upon n plus 1 to the power n plus 1. In place of n you have to put only n plus 1, nothing. So now we will use some high school method. You know that if you have 2 to the power m into n, so you can write 2 to the power m into 2 to the power n. Similarly, 2 to the power n plus 1, sorry, m plus n, then you can write this. Okay, 2 to the power n into this, you can write 2 to the power n into 2. Okay, what is this? You know that 5 factorial is equal to 5 into 4 into 3 into 2 into 1. Okay, you can also write 5 into 4 factorial. 4 factorial is equal to 4 into 3 into 2 into 1. Okay, similarly n plus 1 factorial is equal to n plus 1 into n factorial. Okay, now what about this? You can also write n plus 1 to the power n into n plus 1 to the power 1. Okay, in multiply, add the power. Now this is un plus 1, this is un. Now you have to divide both values. So now un plus 1 upon un is equal to, what about un plus 1? Un plus 1 is equal to this, 2 to the power n into 2 into n plus 1 into n factorial upon n plus 1 to the power n plus 1. Okay, into un, it is upon, so after then it will come n to the power n upon 2 to the power n into n ka factorial. So now you can see this 2 to the power n cancel, n factorial cancel, and this n plus 1 cancel. So you are getting limit n tends to infinite un plus 1 upon un is equal to limit n tends to infinite, you have 2. Okay, then after then you have n ki power n upon n plus 1 ki power n. So okay, both ki power n. Okay, so you are getting limit, this is constant, it must be outside. Okay, limit n tends to infinite. Okay, now take n both side common, this and this, then after then it will cancel, then you are getting 1 plus 1 upon n ki power n. Okay, then you can take limit n tends to infinite, this 1 plus 1 upon n ki power n. In the previous lecture already we have explained 1 plus 1 upon n ki power n, that is converging to E. Okay, go in the Taylor series, then you will get it, how it can possible. Or you can also solve by the help of this method, x plus y ki power n. Okay, put in place of x 1, in place of y you have to put 1 upon n, then after then write the expansion of this, then you will get n tends to infinite, then you are getting, this is E actually. Okay, then you are getting 2 upon E. Okay, now you can see that this is 2 upon E. So this is 2 upon E. Okay, you can see that 2 upon E, that is less than 1. So this is lambda is less than 1. For lambda is less than 1, it means that this is convergent. Okay, this is lambda is, because this is lambda, whatever you are getting, that is lambda. Okay, so lambda is less than 1, then this is convergent. So this is less than 1, that this series is convergent. Okay, so again I am just solving another question. Your concept it will clear. Okay, if you are just facing any problem, pause the video, again listen, then your concept it will clear. Okay, I am erasing it. Now you have this question. I told you that whenever, I am just taking same example, whenever you have such type of question, then you will use the ratio test. Okay, what is UN? Okay, now you can see that 4 into 7, then 4 into 7 into 10 up to so on. So now I am taking 4 into 7 into 10 up to so on, then you are getting 3n plus 1. You can see that 3 1 is 3 plus 1 is equal to 4, 3 2 is 6 plus 1 is equal to 7, 3 3 is 9 plus 1 is equal to 10. Okay, so after then in here also you can see n plus 1 ka factorial. Okay, actually this is n factorial, n plus 1 not n factorial. Okay, so now 1, if you are taking 1 factorial is equal to 1. If you are taking 2 factorial, then 1 into 2. If you are taking 3 factorial, then 1 into 3, 2 into 3. Okay, so this is un. Okay, what about un plus 1? Un plus 1 is equal to 4 into 7 into 10 into up to so on. This value in place of n you have to put n plus 1. So its value is equal to n plus 1 plus 1. Okay, before the same value will come, 3n plus 1. After then you have in place of n you have to put n plus 1, n plus 1 factorial. Now I am improving it. Okay, 4 into 7 into 10 up to so on. This is 3n plus 1, then 3 1 is 3, 3 is 3, 3 plus 1 4, 3n plus 4. Okay, then you are getting here also you can know you can write n plus 1 in place of n plus 1 factorial. You can write n plus 1 into n factorial. Okay, so same thing, n plus 1 into n factorial. Now you have to divide n plus 1 upon un. So what is n plus 1? This. Okay, now I am dividing. Here I am writing also this here. Un is equal to this now. So this will come above. Then you are getting 4 into 7 into 10 up to so on, 3n plus 1. Okay, now you can see that everything is cancelled. Everything is cancelled. N factorial cancel. Then you are getting limit n tends to infinite un plus 1 upon un is equal to limit n tends to infinite. You have 3n plus 4 upon n plus 1. Okay, now take n both side common, then you are getting limit n tends to infinite 3 plus 4 upon n upon 1 plus 1 upon n. Infinite, 1 upon infinite, that is 0, 4 upon infinite, that is 0. So it is converging to 3. Okay, so now you can see that this is 3, this is 3 and this 3 is greater than 1. This 3 is greater than 1. You can see that. So whenever you are getting such type of value, so in this condition you can say that this is divergent, because whenever lambda is greater than 1, then this is divergent. Okay, so what I taught you, how to find whenever you have any problem. Okay, how to just find that, you have to take this test. Whenever you have factorial, then you will use ratio test. Okay, whenever you have, they will change the question. You have to put the logic in your memory. Whenever you have such type of problem, then you have to use this ratio test, and this you have to remember. Okay, whenever lambda is less than 1, then convergence, greater than 1, divergence, 1 is equal to fail. You have to put this logic in your memory. Whatever they will give you the question, you have to use the method, your problem solve. Okay, thank you so much. I think that you understand.